Hi guys, how you doing today? Today I want to give you just an overview of slope and how we work with it, what it means. The Khan Academy assignments are focused entirely on this topic, and period 6, I think you guys are more than able to handle this. Period 2 and 5, this might be useful to you. Um, so let's talk about slope. I'm going to just flip this sideways, and I'm going to just start with a couple of different ways that we can describe slope. If we're looking at a mountain, right? Let's say we have a guy down here and we have our mountain. Okay, looks something like that. Maybe there's a tree here. Okay, another little tree here. He's got a friend. Maybe another peak. Okay. So, slope. It is the steepness of a line. If you look, this mountain climber can climb up this mountain and he can climb down the mountain. All right, when you climb up a mountain, it's a positive slope. I know we've talked about this. When you climb down the mountain, it's that negative slope. Okay, so there's the positive and negative aspect of what slope means. Now, in terms of the graph, when I'm actually graphing something, slope really describes a rise over a run. And another way to describe this is how is it changing on the y-axis and then how is it changing on the x-axis? The change in y over the change in x. That's an example of rise over run. That's exactly what it's telling us. Now, we actually can calculate slope using a formula. And that's when you're given 2 points and you want to calculate the slope between those points. Now, the slope formula happens to be y2 minus y1 over x2 minus x1. And now I'm just going to practice this once. Let's take, for example, our coordinate plane that looks something like this. We have our y-axis and our x-axis. And perhaps we're given the point 1, 0, and the point 4, 3. And our line between those 2 points looks something like that. Now, granted, we have a positive slope. It looks as though a mountain climber would be climbing up the mountain, positive slope. And we now take our points and we have to plug them into this formula. I like to label. Let's call this point x1, y1, and we'll call this point x2, y2. Now, I also like to write these next to each other. So we'll take 1, 0 and 4, 3. And now we know that we're subtracting the y coordinates, 3 minus 0, and the x coordinates, 4 minus 1. And now we have to do some math. 3 minus 0 is 3, and 4 minus 1 is 3. And there's my slope, 3 over 3, which is also equivalent to a slope of 1. And that's your basic slope formula. All right. Now, I know that a lot of us are good at that at this point. Now, I want to show you another aspect of slope that you might not be familiar with, or you might need a refresher. And that's working with slope intercept form. Now, slope intercept form is our basic form of a linear equation or a linear function. And it's always in the form of y equals mx plus b, where m stands for our slope and b stands for our y-intercept. Now, our y-intercept is usually where we begin when we graph a line. Our slope is how we move, our rise and our run. I'm going to write an equation here in the slope-intercept form with a slope and a y-intercept that we could actually graph on a coordinate plane. So let's take the graph y equals 2, and we'll make it a negative 2, x plus 3. Now I'm going to take a stab at writing, or rather drawing, a giant coordinate plane. And I'll try to make it as neat as I possibly can. We have our y-axis, we have our x-axis, and I'm just going to label with lines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there we go. Now, like I said, we begin at our y-intercept. This is where it crosses the y-axis. So I'll go to that point on the y-axis, 3, and I'll just plot my first point of this graph. Then I want to look at my slope. Well, my slope is technically always written as a fraction, so I can always write this as negative 2 over 1. My rise, or my rise of negative 2, and my run of 1. Again, the change in y over the change in x. So this tells me that I really must go down 2 units as I go to the right 1 unit. So I'll go down 2 units and over 1 unit, and I'll plot a point. I'll go down 2 units, over 1 unit, I'll plot another point. And you can see my line is starting to form. Down 2 units, over 1, down 2 units, over 1, and down 2 units, over 1. Now I can do the opposite and go up 2 units and to the left 1 to continue my line. Up 2 units and to the left 1. And now I have plenty of points to plot. There's my line. Now, clearly I have a negative slope with a y-intercept of 3. And I like to label my line with the equation y equals negative 2x plus 3. Now, I'm going to attempt to graph a line with a positive slope. Let's graph this line. Y equals 2/3 x minus 1. Well, I have a y-intercept of negative 1. And I have a slope of 2/3, meaning up 2 over 3. So I will begin at my y-intercept of -1, and perhaps I'll do this in a different color for you. This will be my blue graph. So there I start at -1, and I have to go up 2 over 3. So I'll go up 2 over 3, up 2 over 3, and I can go down 2 to the left 3 to continue my line. And there I go. I put arrows on the end to extend it. Clearly a positive slope. And I'll label it y equals 2/3 x minus 1. My y-intercept is -1. My slope is 2/3, up 2 over 3. And that's using slope-intercept form to graph an equation on a graph. Graph a linear equation on a graph. Now, I want to show you a couple of different types of lines. So if we look at this, I'll just zoom out here for you guys so that if you want to pause the video right here just to look at this page, that's fine. It's a good page of notes. This should help you with those con assignments. All right, so again, if you want to just pause right here, feel free to. I'm going to continue and do some more notes on my next page. So let's just shift over to there. And I want to talk to you about two types of lines that are straight lines, but their slopes are just a little different. So I want to talk about a horizontal line and a vertical line. Now vertical, another word for up or down. Horizontal, we think left to right. Now, let's make a small little graph here. There's my y-axis and there's my x-axis. And I'm going to try to graph the horizontal line from left to right. I'll do it in a different color for you. Let's try a line that looks something like that. Now, I want to know, where does this line cross the y-axis? Well, let's estimate. 1, 2, 3, 4, 5. About where y is equal to 5. Okay, so y equals 5 on that point that I just plotted. Now, if I was to label coordinates here, we go 1, 2, 3, 4. This point right here might be 1, 5. This point right here might be 3, 5. If I went the negative direction, this point here might be -1, 5. Notice every y value is 5. Hence, the equation of this line is y equals 5. Now you're probably wondering, what's the slope? Well, guess what? Every horizontal line has the same exact slope. It's a slope of 0. Now, slope of 0, let's calculate it. I'll take 2 points, x1, y1, x2, y2, and I'll subtract my y values. And I have 5 minus 5, over my x values, 3 minus 1. Well, 5 minus 5 is 0. 3 minus 1 is 2. 0 over 2 is equal to 0. If you don't believe me, use your calculator to check that answer. Our slope of any horizontal line will be 0. There is no rise to the line, so your rise value, your change in y, will always be 0, giving you a slope of 0. Now let's look at the vertical line. So again, I'll make a little coordinate plane here. And perhaps I'm going to make a line in red right about there. And let's label this line some coordinates. 1, 2, 3. Crosses at about the x value of 4. So I know that x equals 4 on that line. And to label other coordinates, perhaps this coordinate right here of 4, 2. Perhaps this coordinate here, 4, negative 2. And maybe this coordinate here, 4, 5. Notice, every x value is 4. Hence, the equation of this vertical line is x equals 4. Now, I know that the slope of any vertical line is that fancy slope we call undefined. Now, an undefined slope has a denominator or a run of 0. The change in x is 0. And I'm going to prove that to you right now. We'll take two coordinates, and let's take 4, 2 and 4, 5. We're going to subtract our y values by my x values. And I see that y2 minus y1 over x2 minus x1 gets me 5 minus 2 over 4 minus 4. And 5 minus 2 is 3. And 4 minus 4 is 0. There's my run of 0. And anything that's divided by 0 is what we call to be undefined. You can't divide anything into 0 parts. It's just not possible. If you ask Siri, she'll give you an explanation about cookies. I know some of you have done that already. But a slope that's undefined technically has no run. It's not moving left to right at all. All right. Now, there are some notes for you if you wanted to take a look at this and pause it at this point. It'll help you on one of your con assignments. And one more point I want to make. It really is ideally for period 6. And the next thing I want to just talk about is rate of change. Now, rate of change is just a fancy word for slope. We can do this all day long. Just analyze word problems. Your Regents Review assignment this week, period 6, is based on writing equations or writing linear functions based on a word problem, based on a context. Now, I'm going to make one up. Let's see, who's been working on these assignments? We'll do Justin's. All right, Wainwright, you've been doing well. Here it is, here's your word problem. Justin is selling lemonade for, I don't know, $1 per cup. It costs, let's say, $2.50 in supplies to start the stand. And we want to write an equation to model the situation. Now, every one of these problems has two bits of information. It has your rate and it has your initial value. Your rate is another word for slope. Your initial value is another word for your y-intercept. Your m and your b in your slope-intercept equation of y equals mx plus b. Now, a lot of the time, m and y will be different variables. Perhaps c for cost, and maybe, actually, you know what? Let's take that back for a second. Let's do P for profits, how much Justin's making, and your rate times maybe your amount of cups you're selling, plus your initial value or your startup fees, right? We'll leave that as B for now. And if you notice, our equation is pretty simple. So Justin's profits are equal to the amount of cups he sells, which he's selling for $1 per cup, minus his startup fees of $2.50. So if we look at the equation in regular slope-intercept form with y and x, we have y equals 1x minus 2.5. That's it. Every one of these problems is the same. All you're doing is finding your rate, finding your y-intercept, and putting it into the form of an equation. All right, now, I know that was a lot of notes for you guys. Okay? Take the time, work through those con assignments, retry them if you need. I'm here to talk. We have a Google Meets today, so feel free to come on and ask questions. And I hope you guys got something out of this. All right? Again, our first page looked a little something like this, in case you wanted to look at these notes again and pause it. But you guys are doing a great job. All right? Keep up the good work, and I'll talk to you soon.